Hi, hello, namaste, welcome to Pardus tutorial. I'm Madhvi, and as you know, in this Pardus tutorial channel, I'm sharing the videos which are related to the physics and which are also useful for IIT and JEE syllabus, and which are useful for the students from 6th to 12th standard students. And I have shared the recent videos which are about just IIT JEE portion. Based on that only, I have done many videos. So if you didn't watch that video, so I'm sharing those links in the description box. You can go through and watch the videos. And now the final another topic I have choose to in this video. So that topic name is reflection of light. Yes, reflection of light in a plane surface, which we have seen in the previous video. If you also didn't watch that video, I will share this previous video link in the description box. You can please watch that. And in the plane surfaces, how the light can be traveled, because we already know, I have explained about this thing. The reflection is a property of light. Yes, so the light can be behave in a different ways. Example, reflection, refraction, many are there. Yes, and dispersion, diffraction, scattering, many are there. So in that, the basic one is the reflection, how the light can be reflected in a spherical mirror and plane mirror. Yes, so actually the topic which the main reason which to take this video, this topic, I have got some suggestions based on the 10th class students. They have requested me to do this video. So based on that only, I have chosen the another topic here rather than the IIT JEE. So even though which will be useful for the 10th class students, right? So okay, fine. So in this reflection of light, but before knowing about the reflection of light in a curved surface, because that is only lesson name na 10th class first lesson is a reflection of light in a curved surfaces, right? So but before knowing about the how the light can be act in the case of the spherical mirrors or curved surfaces, we have to know how the light is travel and how the reflection will be takes place in the case of a plane mirror or plane surfaces. Yes, so these all things only I have explained in the previous video. If you didn't watch, you can please watch the video with using the description box link. So now let me revise that once again with a little briefly. So we'll see the reflection of light in a the reflection, laws of reflection also I have explained, but let me tell you one more thing. If I am taking, this is a opaque medium, which means opaque surface. In this opaque surface, this is an opaque surface, which means coated one side, whether that is a mirror, or you can take it is a mirror, or you can take it is a normal surface, it is a plane, it is a ground, anything, whatever it may be. If the light is falling on it, if it is opaque, we already know the opaque materials will not allow the light to passes through it. Yes. So now here the incident ray, I am taking the eye. This incident ray, where it is incidenting at the point, I already said you that is a point of incident. Yes, point of incident. From this that point, we have to draw a perpendicular line where the light ray incidenting. That line we have to draw a perpendicular line at that point. Exactly for that point, a perpendicular line we have to draw. This is an imaginary line. Normal line is an imaginary line which is there in perpendicular to the point of incident on the surface where the light ray is incident. Yes. So now this is a normal. So where the incident ray is incidenting at the point, from the same point the light ray will also be get reflected. From the same point the light ray will also be get reflect. So this light ray which is reflecting, that one we are calling reflected ray. Yes, this is the incident ray, reflected ray, and the normal light. Yes, according to the laws of reflection, these three lines should be lying in the same plane. That is the first law of reflection, right? And okay, fine, that is the first law of reflection. And now, because where the incident ray is incidenting, from the same point the reflection should be takes place, right? Not somewhere else, not here, not somewhere. So now see, so here the incident ray making some angle with the normal, but before knowing into that, before about it, the incident ray and reflected ray, okay, these two are also having some angle, okay. That angle we can say 90 degrees angle. The angle between the incident ray and reflected ray is what? It is a 90 degrees angle. So now if you see the incident ray making some angle with the normal line, that one we are calling the angle of incident. The The reflected ray making some angle with the normal is called angle of reflection, and based on the second law of reflection, the angle of I, angle of R, because incident angle and also reflected angle both are should be equal. Why? Because the normal line is separating this angle in a two equal parts. Yes, this normal line should be lie exactly in between of the angle which is made by the incident ray and reflected ray. Am I clear, all of you? So now this normal line may equally separating the angle between the I and R. So now this normal line, the I is making angle with the normal is called angle of incident, and same we know, and the reflected ray making an angle with the normal is angle of reflection. So these both will be equal, that is the second law of reflection. Okay now. So now here actually if there is no opaque medium, there is a transparent medium, the light ray will be travel like this now. In the same manner it will be travel like this. Am I clear? The light ray will be travel like this straightly. Am I clear? So but here what is happened, there is a in between a opaque medium was there, that is the reason the light is hitting that light and bouncing back. So that one only we are calling reflection. But here if we are extending the incident ray, okay, if we are extending the incident ray, whatever the angle is made between the reflected ray and these extended incident ray, what extended, I am writing I extended, which means extended incident ray. The angle between the R and extended incident ray we are calling angle of deviation. Okay, deviation means how much the light can be deviate its path from the where previously it is traveling. Yes, previously it is traveling like that, but actually it should have to travel like that, but in between another opaque medium is there or mirror is there, because of that it is deviating. How much it is deviating? This much angle, that is only deviation angle of deviation. Okay, this is the thing which we have seen in the previous video. Yes, so now we'll see reflection of light in a, so this reflection of light will be we are using in a many cases, and how the image will be formed with using the plane mirror also we have seen. And characteristic of a image formed by a plane mirror is what? Virtual image and as well as the erected image, right? Erected and virtual image. So now here if we see the reflection in a curved surfaces. Okay, curved surfaces. So which I have explained about the concave, convex in the last video. Concave mirror and convex mirror. Okay, in the concave mirror, in the case of the concave mirror, if you are taking, it is a pole, and in between we are drawing a in between where we are taking, actually we are taking this mirror from a particular sphere. If it is a sphere, we are taking, if it is a sphere, yes, if it is a sphere, we are taking a half curve from the sphere. So this half curve, the between a middle point between this curve we are calling pole. So but from where we are taking, for that mirror it is having some center, right? So that is the center of curvature. So from the line, whatever the line we adjoining the principal axis to center of curvature, this line we are calling principal axis, PA. And the exactly midpoint between the center of curvature to pole we are calling focus. Yes. So why we are telling this is a concave mirror? Actually with this side is a hollow side we are calling concave surface side, and bulged sides we are calling convex surface side. So in the concave mirror we are coating the convex surface side, which means bulged side we are coating, the another side will act like a mirror. So if you are sending any light ray by looking at the shape of this mirror also we can predict. It will be converge the light inside only. Yes, it will be converge the light inside only. So that is the reason this mirror, this concave mirror is called as a converging mirror. Yes, this is a converging mirror. Okay, and next one. In the same manner, if you are taking convex, we are quoting the concave surface side. The middle point between these two is called pole, and some center will be there for that circle, that center of curvature, and the adjoining line, it's a principal axis. A middle point between the center of curvature and pole is called focus. And if you are taking any light, if you are instanting any light to this convex mirror, it will be, by looking at the diagram also we can predict the light ray is deviate like that, which means diverge like that. Yes, so that is the reason we are calling whatever the light ray we are sending, it will be diverge the light ray only. That is the reason it is a diverging mirror. Okay, this is the diverging mirror. So we'll see in these two different cases, if I am keeping an object in front of a concave mirror, the same object, it will form different type of image. If I am keeping the convex mirror, it will also form different image. And not only that, if I am keeping an object in front of a concave mirror at particular position, based on the different position, it will be form different type of images. In the same manner here, but only two cases are there, rarer cases. If you are keeping it finite distance and infinite distance, based on that, the size of the image will also be changed in the case of the convex mirror. In the concave mirror, what is happening? Based on the position where we are keeping an object, based on it, what will be happen? The image size and image shape and type of image will also be changed. That is the reason the concave mirror can form different type of images in different position of object. Yes. So we'll see. But before to know how the image is forming, we have to know how the light ray will be behave, which means how the reflection will be takes place. When the light ray passes through the pole, it will be behave differently. Not always, if you are sending any light ray, it will not directly divert like that. Based on the way we are sending the light ray, it will be reflect the light in a different manner. Okay. So if you are sending through the focus, if you are sending through the center of curvature, if you are sending parallelly, based on it the reflected ray will be in different manner, it will be reflect. Okay, those all we will study in the case of the ray diagram. So in the next video I will explain about the ray diagrams in a concave mirror and as well as the convex mirror to you. So until that time, you can please watch the video, and thank you for watching the video. And if you think it is useful for your friends and your relatives or anyone, you can please share the video. And if you have any type of doubts, and if you want me to do any type of video, you can just comment below. And thank you for watching the video. Like and share and subscribe the channel. Thank you for watching the video.